Okay, in our last video together, we saw how to handle order of operations. So I wanted to show you the same image that we used at the end of the last video just to remind you to work inside out when you are talking about handling the order of the graphing techniques. Let's take a look at an example on your homework. This says let y equals f of x be a function whose domain is the closed interval -2 to +6 and whose range is the closed interval -4 to +8. Find the domain and range for each of the functions listed below, and you are to assume that f of 2 equals 8 and f of 6 equals -4. Your answer should be in interval notation. Okay, the first function you're given is y equals -2 f of x. This means that you are multiplying first the y's by a value of 2, and then finally the multiplication of -1 would reflect your graph about the x-axis. Now we don't know the shape of the graph. We do know its endpoints, and we know its original domain and range parameters, which is certainly reflected by some of the information in our endpoints. Personally, I think the easiest thing to do is to think about who you're affecting. Are you affecting the x's or the y's? So let's take one of the endpoints for this problem, since this is our first one we're looking at, and see what we think. Okay, if we have an endpoint, and this will not be to scale, but if I had the endpoint 2, 8, and I'm going to multiply the y's by 2, then the new y coordinate would become 16. If I then reflect about the x-axis, the x coordinate is unchanged and the y coordinate is -16. So that's how the graph behaves. So notice we did not affect the input value at all. This means our domain with these operations is unchanged and is still the closed interval -2 to +6. Our range, however, was affected. And notice, in order, our y's were multiplied by 2 and then multiplied by -1. So if I just strip out the y-axis here and I'll look at the original range, which is -4 to +8, the first thing that happens, let me scale this down a little bit. The first thing that happens is that we multiply by 2. So the y value 8 becomes y equals 16, and the y value -4 becomes y equals -8. And then if we additionally multiply each y value by -1, 16 becomes -16, and -8 becomes +8. So from bottom to top, our new range is the closed interval -16 to +8. Okay, for the rest of the examples, I want you thinking which operation affects your domain and which operation primarily affects your range. In part B, the graph that you're asked to obtain domain and range information for is f of 1/2 x. So 1/2 x actually replaces x. We know this to be a horizontal stretch by 2. We saw this in an earlier example. And horizontal operations occur inside the function notation and do not alter the range. So I'm confident my range is the closed interval -4 to 8. The horizontal stretch by 2 means that basically, if you want to think about it like this, your ordered pair 2, 8 1/2 x replaces x, so 1/2 x would have to become the value 2, which means my value would have to be x equals 4. So this guy would move to 4/8. So basically what are you doing? You're multiplying all your x coordinates by 2. So my new domain would be the closed interval -4 to 12. Okay? Alright, next up is y equals f of x minus 3 followed by plus 1. In this scenario, you have first, working inside the parentheses, x is replaced with x minus 3. That moves the graph right 3 units. And then you add 1 to all the y's, so you'll move the graph up 1 unit. Right 3 affects your domain. If I take the original domain, -2 to +6, and I move it right 3, going to the right means I'm adding 3. So this will become the interval, closed interval 1 to 9. The part that affects the range is the part that's vertically up 1. And I think it's easier to see this part if you had basically your range is -4 to +8. When you move up 1, you become -3 to +9, closed interval. For part D, it's similar to part C, so I'll let you try it on your own and check yourself. The curve is y equals f of x plus 2 followed by -3. Ask yourself, which way are you moving horizontally? Which way are you moving vertically? Okay, next is part E. We have y equals f of -x. If -x replaces x, that produces a y-axis reflection. This changes your domain values because you're changing your x coordinates. And think about it like this. If you have this point 2,8 and I reflect over the y-axis, I have the order pair -2,8. So the y coordinate stayed the same. So my range here is still -4 to +8. My domain, however, is reflected about the y-axis. So while I had the domain -2 to +6, I will now have -6 to +2. Okay, likewise, if I'm going to reflect about the x-axis, which is the case in part F, y equals -f of x. Then instead of the point 2,8, I have the point 2, -8. So the input values aren't changed, so my domain is still -2 to +6. My range values become the opposite of what they are, but you need to read them in the correct order. Originally it was -4 to +8. Multiplying all the y's by -1 would give you -8 to +4. Read them bottom to top. And this last guy is sort of throwing you something interesting in the mix that wasn't necessarily covered as a particular graphing technique. You're taking the absolute value of an entire function. Let me briefly illustrate this. You see before you a figure of a graph that I've drawn, just a curve called y equals f of x, passes through the points -1, -1, 0, 0, and 2, 1. If I am taking the absolute value of the entire function, I'm really taking the absolute value of all the y coordinates. So therefore the x coordinates would not change, and therefore my domain is still -2 to +6, the closed interval. Now what about my range? Well, the point 1, -1, if I take the absolute value of the y coordinate, would make the new y +1. 0, 0 would stay the same, and 2, 1 would stay the same. So what really happens here? Well, if your y's are already positive, you get the same graph you already had. But if your y's are negative, they reflect above the x-axis so that all of the y's become positive. Excuse me, let me do that the correct way. Okay, reflecting correctly. Now read your new range, your lowest value here to your high value. Okay, all right, now you can see that this graph, which is not the example we're doing, but the one I want you just to think about to get you motivated, has range 0, 1. So what about our guy? We started out with a range that included all the values between -4 and +8. That means -3 is in there, -2, -1, 0, etc. Okay? 0. All of the values, the y's below 0, are negative. Those would reflect above and become the numbers 0 to 4. You already had the numbers 0 to 8 as positive values. So your net range will be 0 to +8.